In the moment Atlantis's wheels touched down on the runway, it was not just a spacecraft that ended its journey, but an epic chapter in technological history. It was the Space Shuttle Program, the pinnacle of late 20th century aerospace engineering, and a testament to humanity's enduring ambition to push the boundaries of Earth. Since Columbia's STS-1 mission in 1981, the Space Shuttle has been closely associated with NASA and America's pioneering role in space. Unlike short-term exploratory missions like Apollo, the Space Shuttle was designed as a permanent, reusable, and flexible space transport. Each liftoff carried not only astronauts and equipment, but also the belief that space was no longer a foreign place, but an extension of the human world. The Space Shuttle Program embodied an engineering dream to create a spaceflight system that humans could control, operate, return to, repair, and reuse. It represented a time when humans not only wanted to go to space, but also wanted to stay and work in space. A major shift from flag-planting missions to systematic, continuous operations. Yet, in its 30-plus-year journey, the program has experienced both triumph and tragedy. From the historic missions that put the Hubble Space Telescope into orbit, to the construction of the International Space Station, ISS, to the two disasters of Challenger 1986 and Columbia 2003, where technology touched the delicate line between achievement and loss. These things made the shuttle more than just a piece of machinery. It was a living symbol of humanity's entire journey into space, a journey that was both scientific and philosophical. The end of the program in 2011 was not simply a matter of budget cuts or organizational restructuring. It was a strategic decision to shift resources to new systems that were more flexible, cheaper, and could reach farther, to the Moon, Mars, and beyond. But for millions of people around the world, and especially for the generations of engineers, scientists, and members of the public who grew up watching the shuttle rocket into the sky, that July 21 event still had a special meaning, a farewell to an era in which humans learned how to fly and return from space.
When humans go into space and come back. When Columbia lifted off from the Kennedy Space Center on April 12, 1981, it not only marked the first operational use of a reusable spacecraft system, but also definitively announced that a new era in spaceflight had officially begun. In the context of the Cold War, the United States' successful development of a reusable spacecraft system was not only a technical matter, but also a strategic message to the world about its technological prowess and long-term space vision. The Space Shuttle Program was, in essence, a fundamental shift in the way we think about space. Instead of the single, one-way missions of Apollo, the new program pursued a cyclical approach, where space became a continuously active space, accessible in periodic intervals and capable of supporting long-term research, defense, and industrial goals. The design of the Space Shuttle as a flight system that could land like an airplane was a major technical breakthrough. The spacecraft was not destroyed upon re-entry, but returned in a reusable state after maintenance. It was the first time in space history that a manned vehicle had been designed to take off vertically like a rocket, operate in orbit like a research station, and land like a conventional airplane, requiring a complex integration of orbital mechanics, aerodynamics, and extreme temperature protection. During its 3 decades of operation, the 5 shuttles, Columbia, Challenger, Discovery, Atlantis, and Endeavour, flew 135 missions, carried more than 350 astronauts into space, conducted thousands of scientific experiments in microgravity, deployed and maintained the Hubble Space Telescope, an instrument that changed humanity's entire understanding of the universe, and played an indispensable role in the construction of the International Space Station, ISS, humanity's most important platform in orbit to date. The shuttle was more than just a means of transportation or a symbol of American engineering prowess. It was a space laboratory for experimental scientific research, a platform for breakthroughs in medicine, cell biology, fluid physics, and materials technology in microgravity conditions, something that facilities on Earth cannot fully replicate. The space inside the shuttle, combined with the ability of the crew to stay for long periods, allowed for a long series of experiments that opened up a wide range of applications in life, from non-invasive medicine to the development of pharmaceuticals and advanced heat-resistant materials. At the same time, the shuttle was a cultural icon. Images of it soaring into the sky in a white cloud of smoke or landing gently in the Florida sunrise are seared into the minds of millions. It represented a generation that grew up believing that space was a place where humans could belong, no longer a distant, forbidden domain, but a logical extension of our intelligence and technology. The shuttle, by its very engineering, made possible the seemingly impossible. Humans could not only leave Earth, but return, continue to repair, improve, and fly again, this time better, safer, and farther.
Final landing, STS-135 and the flight of history. Under the dim lights of the Kennedy Space Center runway, at dawn, without applause, without the pandemonium of media cameras, Atlantis quietly rolled for the last time onto the ground it had left dozens of times. At 5:57 a.m. on July 21, 2011, flight STS-135, the final mission of the Space Shuttle Program, ended gently, almost silently. There was no grand celebration, no colorful banners or loud speeches, just red-eyed stares in the control room, where hundreds of engineers, operators, and technicians had dedicated their careers to sending humans into space and ensuring their return. It was no coincidence that this final flight was organized with such a minimalist, almost modest structure. STS-135 carried no commercial satellites or new scientific equipment, nor did it carry any groundbreaking experiments. Its focus was simply to deliver the Raffaello multi-purpose logistics module, which contained the supplies, components, and equipment needed to sustain the ISS for at least another year, a point when NASA hoped private companies would be ready to take over the logistics role. And that simplicity carried enormous symbolic weight. The flight was a ceremonial closure, a carefully placed final period at the end of an epic chapter. What made STS-135 special was not its payload, but the historical context it represented. The final flight took place in a changed world. NASA no longer had the budget to maintain its costly space transportation systems. Strategic priorities were shifting from low Earth orbit to deep space exploration, and the concept of space has gradually become an economic domain rather than a national arena. In this context, STS-135 was a pivotal event, ending an era of full state control, paving the way for a hybrid model where the state creates the infrastructure and the private sector plays the role of implementation. The crew of STS-135, just 4 people, the smallest in the entire history of the program, exemplified a pragmatic approach. Enough people to run the mission, no excess, no fanfare. There were not only skilled, but also responsible people who knew that they were carrying on their shoulders a part of the collective memory. They were the last to fly a vehicle that had been the dream of the previous generation, and the first to see that dream come to an end. When they left the command module after landing, they had not only completed a mission, they had closed the door on what would come to be known as the Space Shuttle era. Atlantis, with more than 30 missions spanning nearly 3 decades, was more than just a piece of technology. It was the physical embodiment of a vision that humans could not only go to space, but return, learning, adapting, and improving each time they returned. And when its wheels came to a final stop on runway 15, it marked not only the end of a journey, but also a farewell to a historic period in spaceflight, a period in which people believed that with technology, we could fly into space as everyday flights.
Why did the program have to end? The end of the Space Shuttle Program was not an abrupt decision, but a carefully considered strategic choice, stemming from many intertwined reasons between technology, finance, and the long-term development orientation of the U.S. space industry. Since 2004, after the Columbia disaster, the George W. Bush administration announced a roadmap to end the program, at the same time setting a new vision for NASA towards returning to the Moon and further exploring Mars. During the term of President Barack Obama, this orientation was maintained and adjusted, emphasizing the role of the private sector in low Earth orbit, or LEO, transportation, so that the government could focus resources on deep space exploration goals. The end of the Space Shuttle Program, therefore, is a transitional turning point, not the end of the space journey, but the beginning of a new phase. One of the key reasons for this decision was the high cost of operation. Although designed to be economical through reusability, each shuttle flight actually cost between $450 million and more than $1.5 billion, a huge sum for a space system that was entering its aging phase. The bulk of the cost was not in fuel or personnel, but in the maintenance, inspection, and recovery of the system after each flight. The complex nature of the shuttle, with more than 2.5 million individual parts, sophisticated thermal protection systems, and the need for absolute safety for the crew, made logistics and maintenance costs impossible to reduce to reasonable levels, despite decades of engineering efforts. However, cost was not the only obstacle. Two major disasters, Challenger in 1986 and Columbia in 2003, had shaken the foundation of confidence in the program's safety. Challenger exploded just 73 seconds after launch due to a solid fuel seal failure, while Columbia disintegrated during re-entry due to a heat shield failure. In all, 14 astronauts died, not just personal losses, but also a deep emotional wound for the entire American space industry. These tragedies not only raised serious questions about the sustainability of the design, but also forced NASA to reconsider its entire approach. Was such a complex system, developed from the 1970s technology, still fit for the 21st century? Ultimately, the deeper and more important reason was NASA's vision for the future of space travel and humanity. After 3 decades of focusing on low Earth orbit, where the shuttle primarily operated, the agency realized it was time to look beyond it, both literally and symbolically. Returning to the Moon to establish a permanent base, or even sending humans to Mars, requires entirely new systems, simpler, lighter, more durable, and capable of operating in environments far more hostile than Earth orbit. The Space Shuttle, for all its achievements, is no longer the right tool for that mission. In this end, a strategic shift has quietly taken shape. The role of LEO transportation is gradually being transferred to the private sector, typically SpaceX with the Dragon and Crew Dragon programs, or Boeing with Starliner, while NASA focuses all its efforts on programs such as Artemis, with the goal of returning humans to the Moon, moving towards the foundation for the journey to Mars. The end of the Space Shuttle Program, therefore, is a transitional turning point, not the end of the space journey, but the beginning of a new phase. The legacy of the Space Shuttle Program did not end when Atlantis rolled off the runway. On the contrary, it continues to spread in quiet but enduring ways, in science, in engineering, in technological thinking, and in the human psyche. The program has ended, but it is the end of a chapter, not the end of a space dream. The shuttle's legacy is not just a historical record, but a living foundation for the present and the future. No program has contributed more to the construction of the International Space Station, ISS, than the shuttle. Nearly all of the major ISS modules, from the engineering giants Destiny, Columbus, and Kibo, to the logistics modules and the robotic Canada arm, were transported and assembled on shuttle missions. Thanks to its large payload capacity and large crew, the shuttle has served as a multi-purpose transport vehicle and flying laboratory, delivering both supplies and manpower for mid-orbit construction. The ISS, a symbol of international cooperation between the United States, Russia, Europe, Japan, and Canada, simply could not exist without the shuttle's persistent missions. Alongside the ISS, another scientific icon is closely associated with the program: the Hubble Space Telescope. Launched in 1990 on Discovery's STS-31 flight, Hubble has undergone numerous repairs, equipment upgrades, and component replacements, all done by hand on special shuttle missions. Astronauts have ventured into space to fine-tune each mirror, replace each camera, and install optical instruments with pinpoint precision. The result is that one of humanity's greatest scientific instruments, the Eye of the Universe, is still operating today, sending back images and data that have forever changed our understanding of the universe. Without the shuttle, these human interventions would not have been possible. But the program's scientific legacy extends far beyond its physics achievements. Over the course of its 135 missions, the shuttle carried thousands of experiments, from solid-state physics to weightless medicine to molecular biology to materials research in microgravity. These data are not sitting idle in archives, but are being mined for modern research, from pharmaceutical development to the application of nanotechnology. The shuttle, as a flying laboratory, expanded the frontiers of research by taking science above the atmosphere, where the harsh environmental conditions reveal properties that cannot be replicated on Earth. Beyond all the technical and scientific merits, perhaps the greatest legacy of the program is its inspiration, something that cannot be measured in numbers or charts, but has the most lasting impact. For 3 decades, the image of a shuttle launching into the sky has become a symbol of intelligence, of courage, and of the human capacity to overcome its own limitations. It seeded a generation of space-obsessed kids who grew up studying engineering, pursuing physics, becoming engineers, researchers, and now are driving the global boom in private space. The same people who once taped pictures of Atlantis to their bedroom walls are now writing the next chapter of that dream, this time with SpaceX's reusable rockets, the Artemis mission to return to the Moon, and the ambition to send humans to Mars. The shuttle is no longer flying, but it is still flying, in the space stations it built, in the scientific data it analyzes, in the technology that inherits the old knowledge, and in the human desire for what lies beyond. The end of one chapter is the beginning of another. That is the true nature of legacy.
What's next? That's not a closed question, but an open horizon. After the Space Shuttle Program ended, NASA didn't retreat. It transformed. The new phase of American spaceflight is no longer a one-sided race between superpowers, but a dynamic model of public-private partnership, where creativity, efficiency, and innovation are driven by the market, but still serve the interests of science and humanity. Companies like SpaceX, Blue Origin, and Boeing are not just providing transportation to low Earth orbit, but are helping to reshape the concept of space travel. The emergence of Dragon, Starliner, and especially Starship, with the goal of taking humans to the Moon, Mars, and beyond, marks a fundamental shift in the nature of space access, from expensive and proprietary to flexible, scalable, and economically viable. It is at this juncture that we realize that the end of the shuttle is not the death knell of the dream of flight, but the prelude to a new era. An era in which spaceflight is no longer the privilege of a few nations, but may, in the near future, become part of the human experience. The shuttle was the vehicle that brought us to the door of that possibility. The next step is to walk through it, with new technology, new vision, and unwavering courage. As Atlantis came to a quiet stop that early summer morning in 2011, a calm voice rang out from Mission Control. No flourishes, no exaggerations, but the weight of history. Atlantis, thank you for your outstanding service to your country and to humanity. This is the end of a chapter. It was a farewell, not just to a ship, but to an era where the technology was imperfect, but the aspirations were great. An era where people take risks, trade resources, lives, and even beliefs to reach something greater.